Today we're kind of continuing on with that same idea, some kind of basics of geometry, but instead of talking about points, lines, and planes, we're going to talk about something different called a segment. We're going to learn two different postulates today. Everyone say the word postulate. Postulate. Postulate is just a fancy way of saying a rule in math class, right? So we want to sound fancy, so we call it a postulate. So we're today going to talk about segments, and we're going to talk a little bit about angles. Now, yesterday we talked about lines, which look very similar to segments, but there's something very different about the lines we did yesterday and the segments we did today. What is the difference between the two things? The lines that we saw yesterday and this one, yes? Okay, points are open and some of these points are closed. What else is different, Aiden?
It's not a line that's going
infinite, right? So a line, the other lines before had arrows on them. These have 2 points. So the arrows mean that they would go on forever and ever and ever in both directions. If you've got 2 points like this, that means you've got a starting point and you've got an ending point. So you've got like an actual distance that you can walk or a distance that you can travel. That's a segment. So the segment is part of the line that consists of the 2 points, and these 2 points, I know it's weird, but they're both called endpoints. Endpoints. It's a little laggy. Okay, both of them are called endpoints. Now, yesterday when we talked about lines, when we wrote the notation of our lines, we put, like, we would call this line AC, and right above it we would put the line with the 2 arrows. What do you think we're going to put above it in this one? Yes?
2 dots.
2 dots, exactly. So we're either going to call this segment AC, and instead of putting like a line with an arrow, we're just going to put a straight line right across it. You really don't need the dots. It's kind of assumed that the dots are there. Thank you. And if you don't call it segment AC, what's another way I could call that same segment instead of AC? Look at it. CA. Yeah, I can just flip-flop them. So AC or CA is fine. But again, have to have the line above it to show that it's a segment, and that's important. Okay, because it shows the difference between a segment or a line. Now, the first rule we're going to learn is called the segment addition postulate. If you had to make a guess, what do you think we're going to do with this postulate? We're going to do some adding. Yes, we are. So here's what the postulate or the rule says. If you have 3 points, A, B, and C, at least 3 points, that are collinear. What does collinear mean? On the same line. If you have 3 points on the same line, and let's say B is in between, then we can do a addition problem essentially with these 2 segments. So for example, right, before we look at that, for example, here's Miss Mathem, right? Okay, and I'm gonna take a walk, I'm gonna travel. All right, so first I take 2 steps. And then, oh, I gotta stop because I'm tired, I'm out of breath. Oh my gosh, so out of shape. Then I decide to take another 3 steps. Okay, and then I stop again. How many steps did I take in total? 5. Took 5 steps in total, right? That's exactly what this postulate says. It says, hey, look, here's the first like segment or first part of your trip. I took 2 steps. The second part of my trip, I took 3 steps. In total, the whole thing was 5 steps. That's all that this is. So you're just adding the 2 smaller pieces together to get the larger piece. That's all that this is. So if we write it with like correct terminology here, or correct symbols, I'm going to say this piece here, piece AB. I'm going to put the segment above it, AB, plus the second segment, which is this one right here, which is, what's the name of that second segment? BC. If I add those 2 together, I should get the whole segment. And what do I name the whole segment? AC. Good, or CA. Exactly. Perfect. So again, if I took 2 steps here and I took 3 steps here, I add the 2 together, I get a total of 5. That's it. That's all this postulate says. If you add the 2 smaller pieces together, you'll get the whole thing, which makes sense. So let's do an example. You ready? Let's do some real math. Let's go. What? What? Okay. Example 1. All right. If xy equals 7 and xz equals 30, what is the value of t? So notice I've got 2 segments, right? One smaller than the other. And I'm going to add the 2 segments together to get the whole thing. So what is the name of my first segment? XY. So here's piece 1, XY, plus, what's the second segment? YZ. I'm going to add those 2 together, XY plus YZ, and I should get the whole segment, which is XZ. Good. Now, all we're going to do is plug in the equation or the numbers that are given to us. So we're just substituting in. What is the length of XY? 7. Plus 2t minus 1. Good. The length of y to z is 2t minus 1. And then what is the whole xz? Where'd you get 30? It says it. Yep, it says it right here. So you got to read the question. It's equal to 30. And guess what this is, friends? It's an algebra problem. Yeah, remember I told you guys that geometry is just algebra with a picture? Algebra with a picture. Haha. Here we go. Right? So let's solve the equation. What should I do first? Too slow. What's the next thing that I should do? Ryan, what do you think?
You gotta get the 1 and the 7 together.
Gotta get the 1 and the 7 together. Because they're on the same side of the equation. That's called? Yes, combining like terms. What is a positive 7 and a negative 1?
6.
Good. And what should I do with the 2t? Bring it down. And then bring down my 30. Now what? I get 2t equals 24. And my last step? Oh my gosh, you guys are great. T equals? 12. Now, do I have to do anything else in this problem? No. It just says find the value of t. What if I wanted to check my work, though? How do I know if I'm right?
Plug it in.
Plug it in. Yeah, so instead of a t there, you could plug in your 12. So 2 times 12 is? Minus 1 is? 23. So is 7 plus 23, is it 30?
Yes.
Yes, so you did it right. Good job. Give yourself a pat on the back. Nicely done. That's it. That's all we're doing today. Easy peasy stuff, right? So the 2 smaller pieces added together always gives you the larger piece. So it's piece plus the piece equals the whole. Okay. Could you attempt a problem without me now?
Yeah.
Okay, great. Try number 2. It's the exact same setup. Do you need me to help you set it up, or you think you got it? Huh? It's okay. I can help you set it up if you need help. No? Okay. Same exact way. The piece plus the piece equals the whole. All right, you try example 2. Can totally talk to each other. Yes, Peter.
I don't know which one's number 3 or whatever, but yesterday I didn't finish the paper and you told us to do it for homework and I left my binder.
It's okay. I'm going to give us more time tomorrow to complete. So today I just wanted to get these notes in so we didn't have to do it on a Friday.
All right.
And then tomorrow I'm going to give you guys a little bit of, I'm going to give you a couple of these problems and an opportunity to finish that paper if you didn't finish it. So
Gotcha.
You're okay. You're all good. Actually, why am I doing this? Give me another minute. If you're really like done and already feeling like you want to try example 3, you're more than welcome to try it. Raise your hand if you need more time to solve for X. Okay, I'll give you another minute. Check your answer to the people next to you. Good so far? Good so far? Yeah, you're right there. Last step. Project by itself. Okay, you didn't look like you have this equation set up the same way. You've got it written right over here. This piece plus this piece equals this one. This is the first piece. What do you have to put over here with the second piece?
I was doing it right. I'm so slowed down. So that's magnitude?
Sure, it's the piece plus the piece equals the whole. And then once you have your answer, you may need to plug it in. Because the question doesn't just say find X. The first piece, yeah. Plus, what's your second piece? Good. Equals, and then what's your whole thing? Beautiful.
And the negative one.
Oh, and then one. I just combined together on the left.
Yeah.
No.
Yeah.
Good. Negative. Before we have our ready. Oh yes, beautiful. Oh, we're killing it. Killing it. So you've got it written right up here. So when you rewrote it, you got to see follow the same. So what is EF? What's the length of EF? Correct, minus 1. You're okay. You're okay.
Oh, so you just combine them.
Okay, so now.
I'm so confused right now.
Aggressive with that, man. Alright, so instead of EF, you're gonna write right underneath it 4x minus 1. Now, where it says plus FP plus FP, so put a plus, and what's FP? equals what? There you go. Now that's the right setup. Good, we're looking real good.
Yes. There you go. You got it. You got it. Yeah, so like, you got X. You gotta solve it for like the.
So you've got a plus sign here, you need a plus sign here. And then right now you don't have an equation, right? That's just the first half. You still have to set it equal to EG. So you have to set this equal to 100 and then solve it. Erase this out. Set this equal to 100 and then you're gonna solve it like a multi-step equation. Don't. It's the first example you do on your own. It's fine. Mistakes are okay because now you're not going to make that same mistake again. Okay, let's take a look at the board. Most people look like they were doing great. I saw a lot of them starting on number 3, which is awesome. For example 2, right? You take your first piece, and I like to color code mine, right? So I take my blue piece plus my yellow piece and set it equal to the whole thing. So your first piece is 4x minus 20 plus your second piece is 2x plus 30 equals the whole thing. And how did I get 100?
Because you saw it in the problem.
Because I saw it in the problem. Yeah, I read it. Okay, so once you go through and you solve that multi-step equation, you get x equals 15. But I am not done with that problem. Why not?
Because you have to solve
Good. I have to take that 15 essentially and plug it in. Now, if you plug it into the first one, 4x minus 20. If you're plugging that in, that means you're taking 4 times 15 and then minus the 20. Okay? What is that when you put that in your calculators?
16 minus 1 is 40.
It's 40. Now, this blue piece of my segment is 40. Without plugging it in, what does the yellow piece have to be?
60.
How did you get that, Miguel?
Because 40 plus 60 is 100.
Oh my gosh, 40 plus 60 is 100. Yes, so this has to be 60. But you can plug it in and check. 2 times 15 is 30, and 30 plus 30 is 60. That's a great way to check your work. You got it right. Questions? So the setup is always going to be the same. Every single time you write an equation when we do angle addition or segment addition, you should have something plus something equals something. All right, I'm going to skip example 3 for the moment. We're going to do example 4 because I want to make sure we have enough time to get through everything. And then if we need to come back to example 3 and check it, we will. But take a look at example 4. Now, example 4 is a little bit different than the last 2 we just did. Who can tell me what looks a little different about this problem? Yes, there's a what? What's in the middle? Ah, beautiful. This point C says C is the midpoint. That is like the most important thing you're ever going to read right there, at least in this problem. C is the midpoint. Midpoint means the middle. Okay, so this point C is right in the middle. So think about this logically for a second. If I have a point in the middle of a whole line, so let's say like my arms are 10 feet. They're not, obviously. But let's say my arms are 10 feet, right? And my face is right in the middle of it. What does that mean? Each one of my arms has to be equal. They each would have to be 5. It'd have to be equal, right? Because 5 plus the 5 is going to give me the whole thing of 10. So in this picture, what do you notice about AC and CB? What does that mean about those 2 pieces? They should be what?
Equal.
They should be equal. They should be the same. There's 2 ways to see that. The word midpoint means middle. You will also see these little, these are called tick marks. This is a tick mark. Maybe write that down. Tick mark, T-I-C, tick mark. A tick mark shows that these 2 pieces are congruent, or they are the same. They are equal to each other. That's what that little tick mark means. So for this problem, my setup is a little bit different because I'm not going to add these 2 pieces together. I'm going to do something else with them. What do you think I'm going to do with them? Going to take half of it? Well, that would be really great if I knew what the whole thing was. Do you know what the whole thing is? Did I tell you what AB was? I wasn't that nice, was I? No, but I do know that these two are the same, so they are equal. Yeah. So my equation is going to look like this. I'm going to take segment AC and set it equal to segment CB because they are the same. They're equal. And then I'm going to solve it like an algebra problem. So instead of AC, what am I going to put there? 2x plus 1 equals 3x minus 4. And this I only do this when it says the word midpoint because that means it's in the middle. That's the only time I do it this way. All the other ways, I'm adding the two pieces together to get the whole thing. Now this becomes algebra, your favorite. Oh, okay. What should I move first?
No, we're getting that point.
What? What?
No.
Okay, do you want to answer the question? What should I do first?
Yeah, go ahead.
No, you go ahead. No, like I know what to do. Maybe you could tell me what to do.
Go ahead.
Okay, go ahead.
Okay, so what we're gonna do, is that all of it?
That's the whole equation.
Okay. So like, let me do, what is it gonna do? You're gonna subtract the 1, right? And add it to the 4.
Sure, so hey, you can do that. There's nothing wrong with that. Now, what did I tell you to
being lazy.
No, it's okay. I like to do the x's first, but you do not have to do the x's first. Let's not do the x's. I'll show you. You're gonna get the exact same answer. So how am I gonna move over that 1? What am I gonna do, Juan? By doing what? Add or subtract? Subtract it. Okay. Okay, keep going, Juan. You're doing great.
And now we can get the, oh wait, we're not done. I thought you were gonna add it for me. Okay.
Work from left to right. What should I bring down first?
Before and the 1, you gotta.
Then left.
The x's?
Start with the left. Go to the left to the right. Did you use the 2x?
What are you talking about? Are we not gonna add it?
You're getting too far. That's over all the way at the right. I told you to go from the left. No, you're gonna get it wrong if you do it that way.
Bring down the 2x.
Thank you. Oh my gosh, bro. What do I do with the 1? It does work, but I'm telling you to go from left to right because when the equations start to get longer and harder, going from left to right is a better choice. This is a short and easy problem. Yeah, of course, right now you can do it. But when they get to be like, when I give you like 20 variables, you're going to be like, what? Oh, yeah. Oh, yeah. Just you wait.
Oh, yeah. I want that.
Okay.
So, that.
And then what's -4 minus 1? -5. Yeah. I borrowed $4, then I borrowed another $1. Borrowed $5. Okay, now what?
You can add the 2 with the 3. Right or no? So no, subtract the positive. Oh, yeah.
Hey, that's not nice. It's okay. Look, it's week 2 of school. It's fine. But here's the issue, right? You've got your numbers on the right, which means you have to get your x values to the left. And so now you're going to have to work, unfortunately, with some negative numbers, which is why that's why I was saying moving the x is a little easier. It's not the only answer, but it just makes your life a little simpler to do it that way. All right, how do I move the 3x over to the other side? Subtract it. Now, what is 2x minus 3x? -1x. Which you can write as -x, yep. I put the 1. And then I bring down my -5. You're still not done. Yep, divide both sides by the -1. And I get x equals 5. So again, you're going to get the same answer, but you see how we had to deal with some negatives that way? Which is why I'm saying if you move the x's first, you avoid having to do that. It makes your life a little easier. Technically, yes, but I was just trying to think of an easy number, and I thought you could all take half of 10. So I was just going for something easy. All right, are we done?
No.
Lies.
I gotta plug it in.
Now. Be careful. Actually, think logically. Do I have to plug it into both of these? No, why not?
One side
They're-
is the other side.
Yes, they're exactly the same thing. So plug it into the one that's easier. Which one's easier? This one's way easier. Plug it into this one. So 2 times 5, 10, plus 1 is 11. So AC is 11. Beautiful. What does that mean without doing any math? That CB has to be 11 as well. And then what would the whole AB be? 22, exactly. Just add the two together. All right. Easy peasy. I'm telling you, this class is literally algebra with a lot of pictures. Okay, that's all it is. All right, any questions on those first ones there? Okay, let's flip it to the back. We got to hustle on the back. All right, we're hustling. Now, on the back side, it's still the same idea, except this time instead of segments, we're going to talk about angles. It's the exact same idea, though. You know what an angle is. You've seen an angle before, I really hope. An angle is formed, by two rays with a common endpoint. This common endpoint is called the vertex. And the rays are called the sides. So if you look here at this picture, the sides of this, or the rays, are from B to A. That's a ray. So you start at one point, you go on forever. That's one of the sides, or one of the rays, right over here from B to A. And then the other ray is from B to C. Okay, those are my two rays. This point here that's in the center, that's in between them, this point B is called your vertex. And it's the point where your two rays meet, where they come together. When we name an angle, we always have to use 3 letters. And what's important is that the middle letter has to be your vertex. That is the most important thing. Middle letter has to be the vertex. That's so important. So if I'm going to name this angle right here, I can use 3 letters, and the vertex has to be the one in the middle, the second letter. So I can call this angle A, B, C. You start at A, you go towards B, you end at C. That's one way I could name the angle. And when I name it, I put a little angle sign next to it. Angle ABC. So it just shows me that it's an angle. What's another way I could name this angle? Ooh. CBA. The B has to be in the middle. Has to be in the middle. So you only have 2 choices for ways you could name this angle. The B has to be in the middle. So whatever your vertex, wherever they both come to, the point that they both come to, is that one in the middle. All right, so here's what the postulate says. It is exactly like the segment one, except without a segment, it's with an angle. So here's what it says. If you take the 2 smaller angles and you add them together, you should get the larger angle. So for example, if I take this first angle right here, angle ADB, let's say that was 20 degrees. Write a 20 in there with me. And if I tell you that angle BDC is 30 degrees, what does that mean the whole angle ADC has to be? 50 degrees, right? You just add them together. So in total, it's 50 degrees. That's it. That's all this is. So you add the 2 smaller pieces together, and they should equal the larger angle. Yes? There's not, well, not in this class. There is no such thing as a negative angle. Technically speaking, there is. If you go they're called coterminal angles if you go the opposite way, but no, not in this class. You should always have a positive angle. Don't worry about it. You should have a positive angle. Okay. Let's do it a problem, okay? All right. This is second period, right? Okay. Let's do example. We're gonna do example 5 and example 7. All right, 5. If, now you see this little M right beforehand? This little M means the measure of the angle. So we don't, I told you, mathematicians are lazy. We don't write the whole thing out. This M means measure. So if the measure of angle WST is 50 degrees, so WST, which one of the angles is that? Is that the angle on the left, the angle on the right, or the whole angle?
Right.
The angle on the right. WST. It's this one over here. So I'm going to label it as 50. You should label it too. Okay, if that angle is 50 degrees and angle RSW is 125, RSW is 125. Now, which one is that? The one on the left or the whole thing?
The whole thing.
It's the whole thing, RSW. So if the whole angle is 125 degrees, and I know this angle is 50 degrees, what does that mean this angle right here has to be? How'd you get that?
125 minus 50.
Exactly, 125. Exactly. So angle RST, the measure of angle RST is 75, and it's degrees, because when we talk about an angle, we talk about degrees. There's your final answer. Yeah, same thing. However you think about it is good. All right, one more. We ready? That was easy, right? Piece plus the piece equals the whole thing. That's it. Let's go to number 7. All right, in number 7, it says if the measure of angle FHI is 142 degrees, what are the measures of these two other angles? So I've got this angle on the left, and I'm going to add it together with the angle on the right. And then I should get the whole angle. So what is the name of the angle on the left? GHI. So I'm going to take angle GHI, GHO on the left, the pink one. GHF, that's the one on the left, plus what's the angle name on the right? GHI. I add those two together, I should get the whole thing, and the whole thing is what angle?
122.
Well, yes, but what's the name of it? FHI. This is just an algebra problem like we just did. So what is the measure of angle GHF? 3x plus 6. Plus, what is my second angle over here, my angle in the yellow? 9x minus 8. Equals 142. This is the answer I gave you, 142. And guess what this is, my dears? It's algebra. It's algebra. Okay. Combine like terms. What can I combine? 9 and 3x. So that's 12x. 9 plus 3. Good try. Hey, it's early in the morning. We're okay. What else can I put together on the left? 6 and a negative 8, which is negative 2. Okay. Add 2. Add 2. I'm trying to go quickly. 12x equals 144. And then divide by 12. X equals 12. And then all we have to do is plug in, but I'm not going to plug in because we are like literally running out of time. Okay, so here's what I want you to do. I want you to finish those last examples that are left. We're going to check them tomorrow. Tomorrow, I am going to give you a very small practice worksheet with ones like this. And you will work on that. And if you didn't finish your 1.1 worksheet from yesterday, you can also work on that tomorrow. So tomorrow will be like a practice work day for you, based on what you have done. Yes, my dear.
Is this, do I have to turn this in?
You do not have to turn this in. No, anything that says notes, you never have to turn in to me. These are just practice for you. But try to finish the last two so I can show you them tomorrow, and then we can see how you did on them. All right. If you borrowed a calculator, please go put it back. And everybody give yourselves a pat on the back. You guys did great. You did great today. So great.
Because he said he's gonna give science to other people that are new now. They have that.